Hey everyone, welcome back. Houston Math Prep here. We are going to be working through the integral of secant cubed x dx. It's a little bit of a beast when it comes to doing trigonometric integrals, so we wanted to do a video on this one in particular by itself. The first thing that we really need to do, there's no way to just do a u sub or to integrate this by some sort of identity right away, so we're going to actually split this up into secant squared x times secant x dx, and your intuition at this point might be to try to convert the secant squared x using a Pythagorean identity, get some mixtures of tangents and secants. It turns out if you go down that road, you're welcome to try it, but it turns out that you just end up going in a circle and you end up right back where you started. So at this point in the integral, what we actually need to do is integrate by parts. Now both of these are trig integrals, so Lipit doesn't really help you here. The one thing that you can maybe see is that secant squared x is really easy to integrate, because if we take the integral of that, that would be tangent. So we're going to go ahead and choose that for our dv. So we're going to say dv is secant squared x dx, and then we'll go ahead and say the other part is our u. So u is going to be just secant x. So if we set it up this way, that's going to be giving us that du is then secant x tan x dx. And again, if dv is secant squared x dx, then v is just tangent of x. Okay, so now remember we'll use integration by parts as uv minus integral v du. Okay, so using our uv minus integral v du, we will actually get u times v is secant x tan x minus the integral of v du. You'll notice that du and v both have a copy of tangent in them, so we'll actually get tangent squared x secant x dx from this one. Okay, and so that is equal to our integral of secant cubed x dx. So the next thing to do is figure out how we're going to do this one. Our intuition from before actually works out very nicely with this one. So if we go ahead and change this tangent squared x using a Pythagorean identity, so our original integral, let's go ahead and keep what we've already figured out, which is the secant x tan x part. We're going to go ahead and make this integral of Pythagorean identity for tangent squared x is secant squared x minus 1. So we'll do that. And now what I'm going to do is distribute my secant x in here. It looks like I might be trying to save it as part of du, but now I have everything in terms of secant here. We know that's not the case. So I'm going to distribute that. And we'll keep working through this. So we get secant x tan x minus the integral of secant cubed x minus secant x dx. I'm going to go ahead and split these up and do one more step so that hopefully you can kind of see what is occurring from here on out. So we have secant x tan x minus this integral, so minus the integral of secant cubed x dx minus, I have a negative here, so that would actually be plus the integral of secant x dx. So a couple of things happen here. I'll come back to this in a second. This last one here is a definition that you might know. The antiderivative of secant x is actually going to give us ln of secant x plus tangent x. And we will get a plus c on the end there. The tricky thing is to notice that we have this repeating integral when we do this process. We end up with minus the original integral that we were trying to do. So how do I do this? If you remember from our repeating integrals video, the idea is I simply add this to the other side. So we will add secant cubed x dx integral to this side, and we will also add it to this side. Okay, so on the right side, that will obviously get rid of that term. On the left side, I have this integral plus another one of those integrals is going to give me two of them, right? So I have two secant cube integrals on the left side now. And I don't have any integrals left on the other side, so we'll just copy down what we have on the other side, which is secant x tan x plus this ln of absolute value secant x plus tan x, plus our constant of integration. And the only thing to do now to solve the original integral is to divide everything by 2, all terms here, even the constant, although a constant divided by 2 is still just going to be some constant, right? So we get from this one, integral of secant cube x dx, we get 1/2 secant x tan x plus 1/2 ln of secant x plus tan x plus c. Okay, so that's our answer for this one. Think about all of the things we had to know and do to get through this. First, we had to be able to break it apart. We had to know how to integrate by parts, choose a u and dv appropriately. Once we did that, we got to this point and we had to figure out what to do with this next integral. We had to use an identity, so that was an additional thing. Use trigonometric identities. We distributed. And then we had a repeating integral. We then had to add to both sides and solve to get our end answer. So if you can work through this one, props to you. You're doing great on your integrals and your trigonometric stuff. Keep going. We'll see you in the next video.